Good morning, good afternoon, and good evening, everyone. Thanks for joining us for another Cassandra lunch. Today it's going to be, pardon me, Data Engineers lunch. Good morning, good evening, everyone. Thanks for joining us for another Cassandra lunch. Today it's going to be, pardon me, Data Engineers lunch. Good morning. Sorry about that. We had some audio issues. Let's start that over. Good morning, afternoon, and evening, everyone. Thanks for joining us for Data Engineers Lunch 96. Appreciate you starting your week with us as always. This afternoon, we have a very special guest for us, Barker Herman, a developer advocate at StarTree. We're going to be going through an intro to real-time analytics using Apache Pinot. We're very excited for this topic, and let's go ahead and get started. My name's Akwi Ohiri. Raul and myself are the hosts for this event. We are looking for speakers and sponsors for this event. If you're interested in either opportunity, please reach out to me at the email address listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, all generally surrounding data. You can find out more about these groups at the addresses listed below. So what do we cover here? We cover everything from the ingress and egress of data and everything in between. We cover everything from databases, ETL, data wrangling, and all the tools and processes of the data engineering world. If it's your first time joining us here at Data Engineers Lunch, please go ahead and introduce yourself in the chat, how you found out about our lunch, and any potential topics you'd like for us to cover in the future. We are coming up on our 100th Data Engineers Lunch. We are looking to do something very special for you guys, but obviously we'll give you some more information on that well before then. Group rules, if you have any questions, do ask them. Barker said that she'd like her questions asked throughout the presentation. So whenever you have a question, go ahead and drop it in the chat. She'll be monitoring that as well, and we'll follow up with you there. As I mentioned earlier, please be polite and courteous to others. And this is an inclusive community, so we do want you to share whatever you want, what you know with us, pardon me. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We'd like to thank our program sponsors listed below, also our organizational sponsors. 15-second announcements. If you have any jobs, meetups, hackathons, conferences, or classes coming up, go ahead and drop a link in the chat with a short description of what our viewers and listeners can expect. Data events coming up. We have obviously our Data Engineers Lunch today. Our Cassandra Lunch is coming back after a brief hiatus this Thursday. We do have an LLM bootcamp coming up tomorrow as well. Please visit our website and events page for a detailed list of all the events we have coming up. We do have a packed week coming up here, so please go ahead and check that out. Also, our latest runbook is still available for download. Please grab your copy. It is free while it's still available. I'll be leaving a link to that in the chat below. And I think that takes care of all our housekeeping items. And with that, I'll hand it over to our guest speaker for today, Barker. Barker, over to you.
Thank you so much, Akwi. I am so honored to be here and very excited to start my presentation. So with that, I'm going to share my screen. Let me know if you can see it now.
Yep, we can see it.
Okay, perfect. All right, perfect. All right, so today I'm going to be talking about real-time analytics using Apache Pinot. And this is an intro deck, so not the most technical, but I will be showing you a demo that we built on it. It's an open GitHub repo that I'll share with you so you can play with it yourself. The idea here is that we're talking through it, but we're also going to give you tools to play with it on your own. So how LinkedIn, Uber Eats, and Stripe create real-time dashboards for millions of users. So that's the topic. So first of all, my name is Barker Herman. I have been in the tech industry for 30+ years. I'm going to be talking about the evolution of analytics and how LinkedIn actually implemented this solution, and give you some sample demo and examples. So Let me start. I spoke at this event, the Big Data Fest 2023, and the two very famous gentlemen, Thiago de Faria and Joe Reese, had these questions. They were doing a panel, and these were the questions that came up. So I want to address some of these. So they were talking about 5-year trends in big data, and they talked about streaming API, will data warehouse survive, and integration of LLM, AI, ML, as well as democratization of data warehousing, commoditizing of warehousing. And, Joe commented that most companies don't even have, they're barely doing BI, let alone AI, right? So we're going to address some of these also today. So I am Barka Herman. I'm also the founder of South Florida Women in Tech, and I work as a developer advocate at Startree. And the best place to connect with me is on LinkedIn. I do have a Twitter account. I'm not constantly on it like I am on LinkedIn. So if you have any questions, you want to reach out and talk to me, connect with me on LinkedIn. All right, so let's start with the topic at hand. Analytics, real-time, scale, why, right? That's the question. So let's take a look at history. I remember being a very young, in the 90s, working with a company creating reports for them. So the analytics was the report. And the way we did it was that we would take data from a batch, and we use this tool called Crystal Reports. Nothing against it. At the time, I was very reasonably impressed with this. And then, and then we wrote these complicated reports, and we presented it to our managers and some salespeople, and they were so impressed. People were able to look at sales data for a week, or other data for a whole week, and they were so impressed. So the cadence was kind of weekly or daily. The data was batch, but also the data was shared. So every time somebody hit a report, generate report data, what would happen? It would hit the production database. And yeah, back then that's what we used to do. But anyway, where are we today, right? Today, we're very concerned about data freshness. We're very concerned about query performance, and we're very concerned about scale. So what does that mean, right? Data freshness, I don't want to know yesterday's sale. I want to know if minute to minute something is happening in my sales cycle. Can you imagine Amazon trying to run like daily reports? That would not work for them. For them, the reports have to be like up to the minute, right? Up to the at least up to the hour. Also, query performance is a big deal. So I'll share a story. I used to work for Microsoft, and I was visiting Seattle for a while, and it was a typical Seattle gray fall day. It was raining. It was cold, and so I'm on my cell phone ordering Uber Eats. And listen, when I'm on that, by the time I decide to order Uber Eats, I was hungry, and I was trying to order this. And what happened was, what were the two things I'm looking for? First of all, the food needs to be good. And the second of all, I want to know how much time to deliver. I'm not going to wait an hour and a half for a delivery, right? So up to the minute data freshness and data scale, and also fast. I want to know now what's going on. So you can imagine that the dashboard that Uber Eats has, where you can kind of look at all the restaurants and what the delivery times and what's to order, is very different than the weekly reports that we were creating 2 decades ago, three decades ago. So that's the huge sort of trajectory of where BI is, or dashboards are today. So let's take a look at a use case of LinkedIn. By the way, Apache Pinot was invented at LinkedIn, just like Kafka was invented at LinkedIn. And of course, when LinkedIn is using their platform. People are using LinkedIn platform. Kafka events are generated, right? So there's an event generated every time you click, every time you like, every time you comment, you post something. That's what's happening in real time. And what LinkedIn had was they had a dashboard. So they had this dashboard, who viewed your profile. How many of you have seen this, by the way? And you can go to LinkedIn right now and you can take a look at it. So what this dashboard is doing is it's more than just, hey, I'm Barka Herman, how many people saw my my profile? If you think about that, it's this one tiny bucket, right? It's a bucket of just a number, a counter that you can keep incrementing, and you're saying, Barka, what's so complicated about that, right? That's an easy dashboard to write. Great, but now I also want to see what the sources are from where I'm getting the clicks. So that is, let's say, it's a search engine, it's from your profile page, it's somewhere else. Is it an external link? So that's another, let's say that's 4 or 5 more buckets. So you're going to say, okay, fine. So instead of writing to 1 bucket, I can just write it to 5 buckets. But if you pay attention to that, who viewed your profile, there's also things like, John Doe saw your profile. If John Doe is in your friend circle, then the name shows up. But if John Doe is not in your friend circle, then what happens is that somebody with the title CTO viewed your profile. So that obscurity doesn't come from your profile, it comes from John Doe's profile. Also, the title comes from John Doe's profile. So when I look at my own profile, it's not only telling me people in my circle, my first level connections, my second level connections, their names, but also things like 5 people with a job title, AI engineer, 6 people with the job title recruiter, so your profile. So there's a lot of obfuscation of data happening, but that's not based on your profile view. It's not just a matter of putting it in a bucket. It's a matter of getting data from very different sources. So that's the complexity. So what was happening back before Pinot became a product was they were actually using Elasticsearch-based solution, and they were running 1,000 nodes, and they were serving up 1,500 queries per second. And the user base for LinkedIn at the time was 20+ million users. So that's impressive that they were achieving 1,500 queries per second, 20 million plus users. But 1,000 nodes is problematic. Anyone who's run distributed clusters understands that this is a problematic thing. So let me show you what happened after Apache Pinot. So Apache Pinot was invented, and the solution there was, the result was they went from 1,000 nodes to 75 nodes. They went from 1,500 queries per second to 5,000 queries per second. And by this time, they were serving 70+ million. Right now, it's more than that. But at the time, they were serving 70+ million. So you're like, okay, wait a minute, what happened? So what happened was they realized that there was a need for data warehousing solution that's supported real-time data consumption. And yes, Elasticsearch did it to a good extent. It's a great product, by the way. However, they needed something more robust. They needed something that was faster, more efficient, and was able to create dashboards that had up-to-the-minute data for complex, data types. So let's talk about Pinot. The story of Pinot is that they didn't start out by saying, oh, we need to invent a data warehouse that supports real time. What they did was they actually incrementally improved the product. So here's the building blocks of Pinot. Pinot starts out with a cluster. So they had clusters in Elasticsearch, but so it also had clusters. Then they have tenants. So tenants is for context isolation. So let's say that, the sales context is different than the engineering context. So that is created, achieved by tenant isolation. But on top of that, there is this concept of table. And the table is just a conceptual idea. In reality, a table is comprised of many, 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 many segments. So this is, you could equate it to sharding, but sharding is an afterthought, whereas Pinot was built from ground up to have a distributed databases, because they were moving from Elastic to this new product. So they created this concept of table, which comprised of many, many segments, and each segment keeps track of its own indexes and queries and data and things like that. And it's a columnar store. So that means that data is organized by columns, not rows. And as we know, from the advent of C-store, OLAP type queries perform better on column-based databases as opposed to row-based databases. So that's why they chose this format. So I hear Eric asking, wondering how easy this is to hook up in production. Well, I mean, I'll show you the pizza shop demo, and that will address some of these. But it's very easy, and I'll show you. So hold that thought. So the next thing I want to talk about is what it actually looks like structurally. So we have this concept of a Pinot controller. The Pinot controller is the one that interacts with the ingestion from Kafka. We do use Zookeeper, Apache Zookeeper, which, as some of you know, is responsible for configuration data. So it communicates with Zookeeper for maintaining configuration. And the broker is the one that does the scatter gather part. So you can see that it has multiple servers on the bottom. So you have S1, S2, S3, S4 as shown in the diagram. And then each one of these servers can have multiple segments. In the diagram that I'm sharing here, you can see that each server has multiple segments, and each segment is redundant. So the segment 1, there's a copy of it on S1 as well as S4. Segment 3 is on server 1 as well as server 3, and so on and so forth. And the reason for this is because now you can run parallel queries because the segment is duplicated, right? So this reduces locking, and it also is better for persistence. If there's a problem with a segment, we can take a server down, rebuild it, and things like that. So it's resilient, it's redundant, and it's distributed. Because the scatter gather is done per server, think about it. If you have tons of data and if you have limited CPU dealing with it, then the level of parallelism is low. Because we have multiple segments and multiple servers, we have parallelization not just of data, but also of CPU, so it's more efficient. And the broker does the scatter gather part. There's more complex versions of this. You can have multiple brokers and more optimizations, but I won't go into those because those are more complicated solutions. All right. So one of the reasons why Pinot is so fast is, remember, we started out with, so the structure definitely is one of the reasons. The second reason is because it supports tons and tons of different types of indexes. So remember, we started with a text index. So Elasticsearch text-based indexing. Pinot does support text-based indexes still, and it's using Lucene internally, but it also adds additional indexes. So it has inverted indexes, it has range indexes, it has geospatial indexes, it has JSON indexes, and star tree index. So inverted indexes are faster because when you have, if you're looking up, let's say, give me everyone who viewed the profile for Barca Herman. So Barca Herman is the key here. And where does that data live? All those documents would show up in an inverted index. So then you're going to the index and you're going directly to the documents, and you're not scanning anything. Range index, very useful. So if you think about, who viewed Barca Herman's profile in the last week? In the last week here is key because that's the time series range. So when you're using range indexes, instead of saying, hey, all the data for this week is in this server, this segment, and all the past data is in some other server, some other segment, now you can skip all the historic data. So range index, instead of saying, here's the time, here's the document, here's the time, you can say, hey, in the last day or in the last hour, what it's doing is it's rolling out that data. So it's fast, efficient. Of course, geospatial index, I did share the example of Uber Eats. So as you can imagine, we created geospatial index in collaboration with Uber Eats and other Uber products. And so it uses this hexagonal-based hierarchical gridding system to find locations. Again, I won't go into it because that's a whole hour presentation on its own. But the final one, the star tree index, is a pre-aggregated result across multiple columns. So let's talk about this. Most of you have heard about cubes, right? Data cubes, everyone heard about it? All right. What is the challenges with cubes, right? The challenge with cubes is that the more columns you cube, the more the data storage. So it's a competition between efficiency and data storage. And as you know, the bigger the data gets, it's harder to keep track of it, blah, 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 blah. So, star tree index, all right, star tree index, it's unique because what it's doing is that it's not cubing all the data. It's cubing some of the data and putting the rest of the data in a different bucket. So what does that mean? Let me give you an example. Let's say that I was looking at the web stats for a website, right? Given website. Let's say that I wanted to find out for this website, hey, how many people showed up to the website on a daily basis, hourly basis, whatever. But I also want to know what region are they coming from and what browser are they using, right? So in this scenario, the scenario that I'm sharing with you on the screen, what you would do is you would say, okay, let's say that 60% of my visits come from United States, another 20% come from, I'm just going to say India because I'm from India. So let's say that 60% come from US, 20% comes from India, and every other country is the remaining 20%. Instead of creating a cube for US, another cube for India, and a cube per country, what star tree index does is it creates 3 cubes, one for the top 2, one each for the top 2, USA and India, and the remaining is in this in the diagram D1 star bucket. So think about it. If you're looking for something in the D1 star bucket, since it's only 20% of the data, it's faster anyway. So you're optimizing the performance of the index by not cubing everything. And you're saving space as well. Now let's look at the D2 level, that row. Again, let's say that 80% of the browsers used are Chrome and Edge, and 20% is the remaining. Again, D2 V1 would be Chrome in this case, D2 V2 might be Edge, and D2 star is the remaining browsers. Again, the way this is doing cubing is it's intelligent cubing, it's progressive cubing, and this is based on query patterns. So this is the way. What it's doing is it's taking the best part of cubing and reducing the storage and becoming more efficient. So this is a great invention that Apache Pinot has, and one of the reasons why it is blazingly fast. All right, so let's move to the architecture. So we talked about this a tiny bit. We looked at the controller. The controller is made of Helix, which is the base of the controller, as well as the Zookeeper, which keeps track of all the configuration. And then on top of that, it has the broker, and then it has two flavors of server. So I didn't talk about this before, but one of the challenges that we run into when we're doing, and remember in the first slide, I talked about how when I was running the reports, it was against production data. Well, one of the big challenges of analytics is that, you have real-time data coming in, and it's a message at a time, and it may be super chatty, but it's still low volume. Whereas if you do a batch ingestion, well, guess what happens? All the servers that are doing the batch ingestion get blocked. So in order to address this problem, the Pinot architecture actually separates the offline and real-time servers. So the real-time servers are constantly consuming real-time messages coming in from either Kafka or whatever other messaging service you have. And then the batch is a separate CPU, separate data store process that's ingesting that. And that way it's not interrupting your real-time queries and real-time ingestion. Any questions at this point? Well, I don't see any, so I'm going to move on. All right, so it's time for the demo. And you guys can get to this demo here, github.com/startreedata pizza-shop-demo. Fortunately, I have already downloaded this demo. So let me share my Docker container. So I have Docker here. And what I'm going to do is, it's a complex demo. It has Pinot servers. We're using Streamlit for the dashboard to actually look at what's going on. And then we have an order service that's emulating the orders being generated. So I'm going to hit the start here because it's going to take a couple minutes to get started. And we'll talk through the rest of them. So we have a Kafka service that's running. Kafka is where the messages are being generated. The Pinot broker is the broker that does the scatter gather for the query processing. And we have the enriched dashboard, which is the actual web app that runs the Streamlit dashboard. Zookeeper keeps track of the configuration. We have a MySQL server that has the product database and things like that. And that's what's happening here. Of course, let's take a look. This does take a minute to run. So let's go ahead. And I will do this in front of you so you see that it's not. Yep. So this is Pinot dashboard right here. And it may take a minute to get started because things are deploying in the background. So this is what we're doing is we're simulating a pizza delivery service. And if you look at this page right here, you'll see that what we're doing is we're simulating, the pizza service is simulating orders coming in, and the orders service is then putting it in Pinot, and then we have a Streamlit dashboard. In the MySQL, we have, you know, the list of vendors and also products and things like that. So let's move this out of the way and let's take a look at what's going on with Pinot. So it does take a minute to run, guys. So in the meantime, if you do have any questions, this would be a good time to ask. All right. Okay, we're going to check on the controller, see what's going on. Okay, so it says controller has started. So let's launch this and see what's going on. Live demos are always so much fun. Yay. Oh, here we go. Something's happening. All right. So here we go. We have the Pinot dashboard up. All right. Because of the Docker stuff that I ran earlier, there's going to be some dead servers. So let's make sure that configuration. So just as a interesting point, what happens is that when a Docker, because I ran this earlier today, what happens is that when Docker comes back up, the IPs change of the servers. So I'm going to go and check the Zookeeper. So this is the Pinot dashboard. This comes in when you deploy Apache Pinot, and you can see that it has 2 controllers, 2 brokers, 2 servers, minions. Minions are generally used to run tasks in the background, 1 tenant, a couple of tables, and a task manager. So let's go to the Zookeeper and make sure that the configuration is correct. Okay. And what I'm doing is making sure that these 2 tables are pointing to the correct broker. And it's 98. And I think it needs to be cancel. Let's check again where the server lives. Yeah, I wanted to start it in front of you because I didn't want to just show you a running app, but I wanted to show you how easy it is to run. So bear with me. Okay, so the good server is this guy. So go back to Zookeeper, go to Pinot cluster, and this is what it looks like, and go to ideal states and go edit this ideal state to be the right address. Yes. And also the orders. Oh, it's pointing to the right one. Okay, so in that case, what we're going to do is we're going to go back here and take a look at the two tables. And so we see that there's an order item table, order real-time table, and order items enriched table. And so we can go to the query console, which is this one right here. And let's take a look at the orders and run this query. All right, so I'm not seeing any orders come in yet, which is fine. What I'm going to do here is the Pinot controller is up, but let's see if everything else is running. Okay, let's try this. All right, so this one seems like it has a lot of rows. So this is the order items enriched, and you can see that it used about 3 seconds. Number of docs scanned. Total docs is this. Now pay close attention because I want to make sure that this is running correctly. And of course, it's gone up. You keep running it, you'll see that it keeps going up. So we are ingesting data, in other words. So we're looking at data, we're ingesting data. Now let's see if we can bring up the Streamlit dashboard. I may have to switch to a different browser because this is a demo app. So it's not made for dark mode. Let's take a look at this. All right. Okay. All right, let's take a look at the console and see what is going on. For some reason, the orders table is not being populated. So let me go back to the Zookeeper and make sure that the orders table is pointing to the right server. They both seem to be good. Go back here, take a look at the tables. Huh. First, okay. We'll take a look at the status. Yeah, for some reason this is bad. The orders item enriched table is showing status good, but this one is bad. Let's go back to Zookeeper and see what is going on. It's always fun to do this in real time because, of course, what is the difference here? Okay. Now let's go back, check on my table again. Oh, look at that. Okay, now that we've fixed the table, pointing into the right server, let's query it. And voila, it's getting the orders. So let's run this query. And now at this point, let's go to the Streamlit app and see it can connect to both the tables. So what does this look like? It's slow, but it's going. So what I'm going to do is run localhost 8502. And the reason I brought Edge up here is because I wanted to show you what it looks like when it's not running in dark mode. So here you can see that in the last 1 minute, 895 orders came in. And here's the dashboard of orders per second and revenue per second. And you can also look at the most popular items. And this is connected to the Apache Pinot instance. I'm pulling data from there. So you'll see that it went up 916 and so on and so forth. So, all right, now that you've seen how easy it is to set it up, of course, there's a lot of behind the scenes work here. Eric, I hope I answered your question of how easy it is to hook up. The setup is a slightly complicated thing. However, once it's set up, it's really easy. Nicholas asks, how often do your customers have Kafka working in concert with Pinot? I might have missed it, but does Pinot manage streaming inputs, like, for example, looking at changes to a single Cassandra table? So Kafka is what it was built on originally because LinkedIn was using Kafka. So it's super easy to connect to Kafka. However, if you have a CDC from Cassandra, that can be streamed in also. We do have connectors that work with many platforms, and it's an open source project, people. So there's a lot of projects, there's a lot of momentum in people creating connectors. If there isn't a connector, of course, we can look into it. I don't know specifically the answer to the Cassandra one, but we can take a look at it real quick. So, all right. So it's gone up 948. All right, so any other questions? So here's the Pinot. Just so you can see what this looks like, I can show you what the config looks like. So here's the schema, but this is the incoming order. If I go to the tables, you can kind of see what the config looks like, and the config will show you. So here's a config, and basically this is the Kafka definition right here. This says that, hey, this is a streaming injection piece, and you can see that, what you're doing is Kafka topic name is defined, and what class to use to ingest it. And that's it. here's where the Kafka broker is. So it's consuming from here, and the topic name is orders. Super simple to set up. It's obvious. I'm not going to say it's easy to set up, but it's intuitive. There is some configuration and all that good stuff, and I'm happy to help you with any of that. So, all right, so I'm going to stop with the demo and keep asking questions, guys, if you have any questions. But I want to revisit the slide that we talked about earlier. So remember, the 5-year trend was supposed to be streaming APIs. Well, guess what? Apache Pinot was built streaming first, right? So it was built to manage real-time streaming. So the solution was real-time dashboards, and in order to do that, it had to consume Kafka topics coming in very quickly. So, and you're looking at it in the demo. Will data warehouse survive? Yes, only if the data warehousing becomes more customer facing. And we saw that in the, Uber Eats. We're looking at Stripe dashboards. Stripe uses it. LinkedIn, of course, we started with one LinkedIn use case and we built Pinot, but now more than 70 views on LinkedIn use Apache Pinot and growing all the time. Integration with LLM, AI, ML. There isn't any LLM, AI, ML in it, but it has a very, very robust plugin system. And we're also building apps on top of Apache Pinot. So Third Eye is an app that we built for anomaly detection. Imagine doing anomaly detection in real time, right? So that's an example. And we have customers who've taken that anomaly detection and added AI models to it and build stuff on top of it. Also addressing Joe Reese's comments, democratization of data warehousing. Here we go. Apache Pinot is the solution. It's built on that principle. Commoditizing data warehousing. So yeah, these user-facing dashboards, whether it be on Stripe, whether it be on LinkedIn, Uber, that's an example. Most companies barely are doing BI, let alone AI. Well, definitely we can help you with the BI, and we can help you with a robust platform that allows AI to be built easily on top of it. Okay, and then I want to also share some of the companies that are using it right now. So LinkedIn is, Zoho uses it. There's a ton. This is an older slide. There's a ton more. So we're working with many companies. There's a lot of interest because dashboards are moving from isolated, limited viewership to a very robust, built for everyone, right? So it's a paradigm shift in dashboarding, and so many people are using it right now. People like Stripe, WePay, Walmart, Target, NVIDIA. Wherever you can imagine a customer-facing dashboard, you can use this technology. All right. So I will happily take questions. Let me get an idea of what time it is. We have plenty of time. All right, happily take questions. Eric, Nicholas, any other additional questions?
Yeah, so if you have some questions, go ahead and drop them in the chat. While people are putting in their questions, I do just want to remind everyone to check out our events page. We do have a packed week. Obviously, starting with our data engineers launch, which we just covered, we also have our LLM bootcamp that's starting up tomorrow. It's going to be a weekly series. I'm leaving a link to that in the chat. Go ahead and do register now. And if you have any questions, please leave them in the chat. I don't see any questions, Barker. Let's just give them a couple more minutes. Barker, I want to thank you again for a fantastic presentation. We really did appreciate having you on. I may be reaching out in the future. We're trying to plan something for our 100th episode. Maybe we could work together again. We'd love to have you on again. This was a great presentation. It doesn't look like we have any other questions coming in. I want to thank everyone for joining us. We really appreciate you starting your week with us. Please do reach out if you have any ideas for what you'd like to see in future lunches, and also our 100th episode. We do have a question coming in from Nick. Could you go back to the summary of the components for the demo? And
yeah, definitely. And if you go to the Git repo right here, so this is the Git repo. It'll give you a Docker Compose file that'll build it all, but here's the Docker desktop of what is being deployed. So obviously a lot of it is parts of Pinot, so Pinot server, Pinot broker, Pinot controller, zookeeper. There is Kafka, and then the add-ons that are specific for this demo are, of course, well, I mean, we deployed Kafka because that's where the ingestion is happening. We have MySQL, where the product database and things like that, and then we're running Streamlit. So that's this dashboard enriched Docker container that's running Streamlit, the app that we built using Streamlit for the dashboard itself. But yeah, definitely go to this URL, github.com, startree data, pizza shop demo, dashes between each one of them. Mobile phone says, I'm wondering how Pinot compares with other technology like Splint, Spark, Druid, etc. So there's an excellent write-up on this where we did side-by-side comparison between Druid and other real-time analytics solutions. Some of them are, so this came out of necessity, right? So I'm just going to say this, look, you know, they're all great products. This came out of necessities. One of a few of the things that it does is it's not just time series data, it supports batch data. That's one of the winning points. Additionally, it'll do things like it supports upserts, which is great. And the startree index is a game changer for, you know, the kind of speed. So let me see if I can find the side-by-side comparison between the servers that's on the blog, and see if I can. Yeah, so this one is good because it's actually comparing. Here, I'm going to share this in the chat real quick. So this one is comparing 3 real-time servers side by side, and it does a good job of doing that. All right.
I think that does answer all the questions. Thanks everyone for putting your questions in the chat. Again, Barker, I'd like to thank you again for a fantastic presentation. It looks like people really enjoyed this. The chat's going up. We really do appreciate that. I want to thank everyone that's watching live and anyone that's watching this a little bit later. We'll be back same time, same place next week. And we'd like everybody to join us then again. Again, Barker, thank you so much, and we'll see everybody next week. Thanks, everyone.
Thank you.